this is a 7th grade math lesson talking about inverse operations. So this really coincides with our chapter 4 study of equations and really just introducing the idea of inverse operations or opposites when it comes to addition and subtraction. So I've just given us 4 problems here. These are actually problems that I took off a recent riddle page that was an assignment for my 7th grade math students. And I just want to take a look at how to show those inverse operations. This is a chance for you to get full credit, and this is critical because one day the equations get much more difficult. And if you can't show your every line by line step, then all of a sudden there are some errors. If one small thing goes wrong, the whole thing is wrong. So for that reason, we really want to be careful about our organization today. If you take a look at this first one, it says I have y plus a negative 4 equals 9. I don't love this font. That negative 4 got really huge, but I can tell that there's an addition happening here, so that negative must be glued to the 4. Well, your general rule is to isolate the variable, get the king alone. So to do that, this negative 4 is bothering him. Well, I need to think to myself, the opposite of adding a negative would be adding a positive, or the only way to get rid of a negative 4 is to put a positive 4. But there are 2 rules when we're working on isolating variables. The first is identify the king, right, to get him alone. The second would be show balance in your inverse operations. So I can't just show it on the left side of the equal sign, I must also show it on the right. I strongly encourage my students as they're just beginning to turn this into 2 separate sides of the equation. So what I do is I find that equal sign and I kind of draw a column divider down, and I also draw a big equation bar underneath the work that I'm doing. So on the left side, I notice if I had negative 4 and a positive 4, those would actually cancel out or get me 0. So I could rewrite this. I still have the y, I still have addition, but I might say y plus 0. And on the other side, I would say 4 plus 9 gets me 13. Well, if you notice, this column divider, it's separating 2 sides of my equation. I also say it's separating my king from the constants. So I bring down the drawbridge, or the equal sign. This is not a final answer. You'd want to clean it up, and you could do that by taking out that 0. And we will find that y equals 13. We isolated the king, we got the variable alone, and we used balance in the kingdom to do it. This looks really nice. These are the inverse operations I'm referring to, where I show what I'm doing on both sides of the equation. It has to happen twice, once on each side. I'm going to take a look at this next problem here for you. And I noticed it says a take away 10 equals negative 6. Well, I noticed something. The king, or my variable, lives on the left side this time, so I only care about the things on the left side of this equal sign. Well, they're trying to take something from my king. They're trying to create a problem. They're taking away 10 things. Well, the opposite of taking away 10 things is adding 10 things. So if I see that they're subtracting, I'm going to add. If I see that they're adding, I'm going to subtract. That's the idea behind inverse or undoing operations. Now please remember, you can't just do that to one side of the equation. You must show it on both. This is that idea of inverse operations. Well, now if I were to simplify a little bit more, I notice if I took 10 away, or I was at maybe even a negative 10 if you want to see it that way, and I gave you 10 back, these would cancel out. You'd be left with a plus 0 gets us, ooh, this is interesting, different sign subtract, huh? 10 take away 6 is 4, and there are more positives and negatives. It would be a positive 4. We'll just do a quick cleanup step. We will say that the king is worth 4. A, or king variable, is worth 4 in this problem. Let's try another one. I see another addition problem coming at us, and I'm guessing that we could probably figure out what number needs to go there in our heads. But the problem is we have to show those inverse operations because the problems get so much more complex with equations. We need to be ready for anything. So we start small. We start with something we can do. Well, which side does the king live on? Well, he lives on the left. So I'm going to show that I'm separating the left from the right here. And I'm going to say, well, I notice that they're adding 7 things to my king. You probably shouldn't add anything to my king. I'm going to show you the opposite. The opposite of addition is subtraction. This is also showing an inverse operation. But if you do it to the left, you must do it to the right. This is talking about balance in the equation, or in the kingdom. Well, let's look at what happens here. If I had 7 and you took 7 away, poof, I'm left with 0. And I still have a king, of course, and I still have addition. And on the other side, I know that 2 plus a negative 7 gets me a negative 5. The only way to keep my king safe is to bring down the drawbridge, also known as my equal sign. And I might do a rewrite step here just to get this cleaned up a little bit. I could tell you u equals 5. That's a good final answer. This last one we're going to look at is a little more complex because it has some funny notation hidden in here. And this actually happened on your riddle recently, so I'm giving you an example in case it's got you stumped at home. So notice, I'll draw a line down the equal sign showing two different sides of my equation. This really separates the left from the right. Well, if you notice, my king doesn't live on the left. He lives on the right. Oh, different perspective. That's nice. I'd love a castle on the right side. Who am I kidding? I'd love a castle. So if you take a look on the right side here, I see that we're taking the king, or the v, and we're subtracting a negative. That's kind of a funny notation, isn't it? What happens when I see a double negative? Well, I could change a minus to a plus, change the sign of next. It's really the same as just adding a positive. Oh, well, now I see that they're trying to add problems or issues or numbers or constants to my variable. I'm going to fix that. Whenever I see addition, I know I can subtract. So the opposite of a positive 31 is a negative 31, or the opposite of adding 31 is taking away 31. I've got a plan for my inverse operation. If I do that to the right, you must do that to the left. This is called inverse operations. We show them twice on both sides of my drawbridge, or my equal sign, or my equation. All right, well, what happens here? I still have v on the right. I still have addition happening, and oh, positive 31, negative 31 cancel out. Poof. I'm left with 0. And on the other side, I had negatives. Oh, this is same signs, add and keep, a rule that we learned early on with integers. It looks like I'm going to get a negative 35. The only way to protect your king in this very moment is to bring down the drawbridge. So here we could write negative 35 equals v plus 0. We can't be done yet because this looks a little bit messy for a number of reasons. I noticed the 0 doesn't have to be included, does it? So we need to get rid of that. And who should always come first in the kingdom, or at least in algebra land? The variable. So in this case, we want to do a rewrite step. We want to put the variable first. V equals negative 35. This is the idea behind inverse operations. Not only do we have to identify the two different sides of our equations and decide which side the king lives on, because that's the side we care most about, we also have to remember to show inverse operations. We show them twice, once on the left and once on the right for each equation. There is a way of checking to see if your answers are solid and good. Of course, if you're doing the riddle, you'll just see if it works out in the riddle. But if you're not, you could actually use some substitution. For the second problem here, I could take out the a and put in a 4. And I could say to myself, what is 4 plus a negative 10? Oh yeah, it's negative 6. It checks out. For the first problem, I could do the same thing. I could take out the y in the original equation and say, oh, that's not a y anymore, that's a 13. What's 13 plus a negative 4? Oh yeah, different sign subtract, I'll still get 9, and it will be positive. The farther number was positive. This checks out. You can try the same idea with substitution on all of these, especially when if you want to be sure that your answer's on the right track. If it doesn't line up in the riddle, this is one way of double checking, and you might need to go back and double check your inverse operations, also known as inverse ops in here. All right, we are returning to inverse ops when I see you again. We will be adding on, or building on, I should say, with the operations of multiplication and division. Inverse ops, continued next time.